This video, we're going to talk about 5.1.3, which are spring mass systems with driven motion. And so these are going to be non-homogeneous linear differential equations when we are setting them up. So it starts off looking like m d2x dt2 plus beta dx dt plus kx is equal to little f of t, and that's going to change into x double prime plus 2 lambda x prime plus omega squared x is equal to capital F of t once we divide everything through by m. And then we're going to be able to solve that with our methods that we've already used for homogeneous, but we're going to have a longer process here where we have a complementary and a particular solution. And we're going to use our methods of undetermined coefficients, or whether that be the superposition principle or the annihilator approach, or you can use variation of parameters, even though I won't be doing any problems where you need to use that to solve these problems. So let's go ahead and let's look at the first problem here, which is number 33 from the book. And it's going to say that a mass weighing 16 pounds, so mg equals 16 pounds, meaning that m is equal to half of a slug, stretches a spring 8/3 of a foot. So F equals KS. So 48 equals 8K. K is equal to 6. And that's in pounds per foot there. And let's go ahead and what else do I need? The mass is initially released from rest. At a 0.2 feet below equilibrium. And the subsequent motion takes place in a medium that offers a dampening force is numerically equal to half the instantaneous velocity, so beta equals 1/2. Find the equation of motion if the mass is driven by an external force equal to little f of t is equal to 10 cosine of 3t. So we found K. Let's go ahead and set up our equation here. So 1/2 x double prime plus, and then beta is 1/2 x prime plus k is 6. X is equal to 10 cosine of 3t. So that makes my equation x double prime plus x prime plus 12x is equal to 20 cosine of 3t. And I'm going to look at the auxiliary equation, m squared plus m plus 12 is equal to 0. There are no factors of 12 that add up to be 1. So I think that this probably has complex solutions to it. So half of the middle number squared is a quarter. And this is m plus 1/2 squared is equal to negative 48 plus 1 is negative 47. So that's root 47 over root 4 is 2, and there's an I from the negative. So, sorry, this is negative 47 over 4. Getting ahead of myself, m plus 1/2 when I take the square root. That's plus or minus root 47 over 2i, and m equals negative 1/2 plus or minus root 47 over 2i, giving me an xc, a complementary solution of e to the negative 1/2 t, so e to the negative t over 2, c1 cosine of root 47 over 2t, plus c2 sine of root 47 over 2t, like that. And my x c prime, because I'm going to need that in a little bit here, is going to be negative 1/2 e to the negative t over 2 times c1 cosine of root 47 over 2t plus c2 sine root 47 over 2t. And then that's the first half. And then this is plus e to the negative t over 2 times, and the derivative of the inside. This is going to be a negative root 37 over 2 c1 sine of root 37 over 2t plus root 37 over 2 c2 cosine of root 37 over 2t, like that. I know I kind of squeezed that all together. Let's see if I can simplify that a little bit. Xc prime of t is going to be e to the negative t over 2 times, and then for my cosine piece, I'm going to have negative 1/2 c1, and this cosine piece is plus root 37 over 2 c2 cosine of root 37 over 2t plus, and then for my sine piece, I have c2 minus root 37 over 2 c1 sine of root 37 over 2t, like that. And now it's time for me to find my xp. So my xp is going to contain a cosine of 3t and a sine of 3t. Plus, if I said a twice, I meant a and b, like that. There's no 3t's that are in my xc, so I should be good here. I need to go out to the second derivative. So xp prime is equal to negative 3a sine of 3t plus 3b sine. This should say cosine, or this should say sine, and this should say cosine. And then negative, positive, good. XP double prime is equal to a negative 9a cosine of 3t minus 9b sine of 3t. So going by the equation up here, I need x double prime p plus xp prime plus 12xp to be equal to my 20 cosine of 3t, because my other piece here should all be equal to 0. So it should be this particular solution that's giving me what's on my right-hand side here. So I have cosine of 3t times, and I have a plus 3b, or negative 9a, reading this way to this way, minus plus 3b plus 12a. Okay. 3b plus 12a. So that is this negative 9a, this positive 3b, and then I need 12 of these xp's according to my formula here, plus sine of 3t times, and then I need this piece, so negative 9b. Then I need this piece minus 3a. Then I need 12 of this piece, so plus 12b. So that's going to be, let's see, so that's 3a plus 3b cosine of 3t plus, and then that's going to be negative 3a minus 3b sine of 3t, and that needs to be equal to my 20 cosine of 3t. So 3a plus 3b needs to be equal to 20, and negative 3a minus, plus 3b needs to be equal to 0. All right, so let's do this by elimination. 6b is equal to 20, and b is equal to 20 over 6, which is 10 over 3. And if that's the case, then we have negative a plus b equals 0, so b equals a. So a is also equal to 10 over 3. And my xp is going to be equal to 10 thirds cosine of 3t plus 10 thirds sine of 3t. I'm also going to need my first derivative here in a second. So this is going to be negative 10 sine of 3t plus 10 cosine of 3t. All right. So what I want to do now is I want to find what x of t is, which is going to be xc plus xp, which is going to be xc was right up there. So that is there, e to the negative t over 2 times c1 cosine of root 37, root 47. I don't know why I want to keep writing 37s over 2t plus c2 sine of root 47 over 2t, and then plus this xp right here. So plus 10 thirds cosine of 3t plus 10 thirds sine of 3t. Why do I need all that? Because I need to find what x of 0 is here to help me solve for c1 and c2. So that's going to be 1 times c1 cosine of 0 plus c2 sine of 0 plus 10 thirds cosine of 0 plus 10 thirds sine of 0. So that's 0. That's 0. So this is going to be 1 times c1. So c1 plus 10 thirds times 1 is 10 thirds is equal to x of 0, we were told was 2, which is equal to 6 thirds. So C1 is 6 thirds minus 10 thirds is a negative 4 thirds. Now let's look at x prime of t is going to be equal to xc prime plus xp prime is going to be all the stuff that I wrote up here. Right there. Xc prime of t, e to the negative 2t or t over 2 times c1 negative 1/2 c1 plus root 37 over 2 c2 negative 1/2 c1 plus root 37 over 2 c2 cosine of root 37 over 2t. Keep writing 37s, they're 47s. Sorry. All right. And then plus a negative root 47 over 2 C1 minus 1/2 C2 times sine of root 47 over 2t. That's my xc prime plus my xp prime is going to be a negative 10 sine of 3t plus 10 cosine of 3t. And I need all that so that I can find x prime of 0, which is equal to 1 times negative 1/2 c plus root 47 over 2c2 cosine of 0 is negative root 47 over 2c1 minus 1/2 c2 sine of 0 minus 10 sine of 0 plus 10 cosine of 0. So sine of 0 part is going to go away. Sine of 0 part is going to go away. And I'm left with negative 1/2 c1 plus root 47 over 2 c2 times 1 plus 10 times 1 is equal to x prime of 0 is 0 because it started from rest. So that tells me that if I want to multiply everything by negative 2 here, I have c1 minus root 47 c2 minus 20 equals 0. So c1 minus root 47 c2 equals 20. My other equation that I had here was c1 is negative 4/3. So let's deal with that. Negative 4/3 minus root 47 c2 equals 20. Going to multiply everything by 3 here. Negative 4 minus 3 root 47 c2 equals 60. Add 4 to both sides. Negative 3 root 47 c2 equals 64. c2 equals negative 64 over 3 root 47. Normally we'd rationalize, but the book isn't going to do that, so I won't do that either. And I'll write my answer here as my xc plus xp. My total xt here is x of t is equal to e to the negative t over 2 times negative 1/2 of c1 was negative 4/3. Sorry, I'm ahead of myself. Of negative 4/3 cosine of root 47 over 2t. And c2 is negative 64 over 3 root 47 sine of root 47 over 2t. that's my XC part. And my XP part is still going to be plus 10/3 cosine of 3t plus 10/3 sine of 3t, and that's my total solution x of t there. So you can see those are longer problems because we have to have a non-homogeneous equation here for driven motion. All right. Let's look at our next problem, which will be 35 from the textbook. And it says back in here, a mass of one slug, which means that I have a weight if I need it, mg is 32 pounds. When attached to a spring, stretches it 2 feet, so S equals 2 feet, and F equals KS, so K equals 16 pounds per foot. All right. And then comes to rest in the equilibrium position. So at time 0, x0 is 0 feet, and x prime of 0 is 0 feet per second because we're at rest at equilibrium. Then the external force F of t is applied, and F of t is equal to 8 sine of 4t. And find the equation of motion if the surrounding medium offers a dampening force is numerically equal to 8 times the instantaneous velocity. So that tells me that this is going to be m is 1, so this is just x double prime plus dampening force 8x prime plus k is 16, x is equal to little f of t, it's 8 sine of 4t, and since m was 1, this is also my capital F of t here, so I'm going to be looking at the auxiliary equation m squared plus 8m plus 16 is equal to 0, which is m plus 4 squared equals 0, which gives me m equals -4 with a multiplicity of 2, giving me an xc equation of e to the -4t times c1 plus c2t, and that will give me same thing here as c1 e to the -4t plus c2t e to the -4t if you prefer it to be written that way. Xc prime, when I need that, is going to be -4 c1 e to the -4t plus c2 e to the -4t minus 4 c2t e to the -4t. So that is going to be xc prime is equal to e to the -4t times c1 plus c2 minus 4c2t, sorry, minus 4c1 plus c2 minus 4c2t. All right. Now I'm ready to think about XP here. And XP is going to be equal to, let's see, do we have, we don't have any sines or cosines in XC, so we have A sine, no, A cosine of 4t plus B sine of 4t. And so XP prime is going to be 4 negative 4a sine of 4t plus 4b cosine of 4t. XP double prime is equal to negative 16a cosine of 4t minus 16b sine of 4t. And I want what XP double prime plus 8 XP prime plus 16 XP is going to be equal to. And so that's going to be XP double prime. So for cosine and for sine, cosine 4t, sine 4t times, and then let's give myself a little bit more space here for sine. Okay, so negative 16a, negative 16b. Then I have 8 times x. So this is minus 32a plus 32b. And then 16a and 16b. So those cancel, that cancels. And this leaves me with XP double prime, 8XP prime plus 16XP is equal to 32b cosine of 4t minus 32a sine of 4t, and that needs to be equal to 8 sine of 4t. So 32b equals 0, b equals 0, negative 32a equals 8, a equals negative 1/4. So xp needs to be equal to negative 1/4 cosine of 4t, and then xp prime is going to be equal to sine of 4t. That lets me know that x of t is going to be e to the negative 4t, c1 plus c2t minus 1/4 cosine of 4t, making x of 0 equal to c1 minus 1/4. And we're starting at equilibrium. So that means that C1 is equal to 1/4. X prime of t is going to be equal to e to the negative 4t times, we said, negative 4c1 plus c2 minus 4c2t. And then we have our xp part here. X prime p is sine of 4t. So when x prime of 0 is in there, that is negative 4c1 plus c2 plus nothing is equal to 0. And a was negative 1/4. I'm sorry, c1 was 1/4. So negative 1 plus c2 equals 0. c2 equals 2. Just a second here. C2 is a positive 1. So we have x of t is equal to c1 is 1/4 plus c2t is just regular old t. This is e to the negative 4t times that minus 1/4 cosine of 4t, or we can distribute this and call this 1/4 e to the negative 4t plus t e to the negative 4t minus 1/4 cosine of 4t. Very good. Now let's go ahead and look at another problem. Number 37. And this one is going to be metric. And it says when a mass of 2 kilograms is attached to a spring whose constant K is 32 newtons per meter, comes to rest in the equilibrium position. Starting at t equals 0, a force equal to F of t is equal to 68 e to the negative 2t cosine of 4t is applied to the system. Find the equation of motion in the absence of dampening. So my beta equals 0 here. I'm going to have undamped motion. So this is going to be m x double prime plus 0x prime plus k is 32x equals 68 e to the negative 2t cosine of 4t. And let's make that x double prime plus 16x equals 34 e to the negative 2t cosine of 4t. Much simpler equation here. I have m squared plus 16 equals 0. M squared equals negative 16. M equals plus or minus 4i. So my xc is going to be c1 cosine of 4t plus c2 sine of 4t. And when I need it, that means that xc prime is equal to -4 C1 sine of 4t plus 4 C2 cosine of 4t. My xp here is going to be equal to, on the, it's going to be a e to the -2t, a cosine of 4t plus b sine of 4t. So like that. So xp prime -2 e to the -2t, a cosine 4t plus b sine of 4t, then plus, leave this part alone and differentiate this part. So -4a sine of 4t plus 4b cosine of 4t, which makes this xp prime equal to e to the -2t times -2 times all this. That's -2a plus 4b cosine of 4t, and then -2b minus 4a sine of 4t, like that. And then xp double prime equal to a -2 e to the -2t times all of this. Plus, leave that piece alone and differentiate all of this. That's a -8, positive 8a minus 16b sine of 4t, and then this is a -16a minus 8b cosine of 4t, and going to turn that into e to the -2t times, and this is going to be 4a minus 8b for that cosine part, and this cosine part is minus 16a minus 8b, so that's cosine 4t plus, and then this sine part is -2 times that, that's 8a plus 4b, and then this sine part is plus 8a minus 16b. Slide this over a little bit and zoom out here. Not that much. Sine of 4t, like so. So this is x p double prime is equal to e to the -2t. 4a minus 16a is -12a. And then -8b minus 8b is -16b. Cosine 4t. Up here. So -12a minus 16b, yeah. And then 8a and 8a is 16a. And then 4 minus 16 is -12. Okay. So now we need, the equation was xp double prime plus 16xp prime, no, plus 16xp needs to be equal to 34 e to the negative 2t cosine of 4t. So we have, so let's forget right now about the e to the negative 2t's. They're going to stay there. What I'm interested in here is that I have one of these parts. So negative 12a minus 16b for my cosine part, and 16a minus 12b for my sine part. Then I have 16 of the original, and the original is a of the cosines and b of the sines. So 16 of those needs to be equal to 34 cosine of 4t. That's what I'm going to look at there. So 16 minus 12, that's 4a minus 16b cosine of 4t plus, and then 16a plus 4b is sine 4t equal to 34 cosine 4t, and there's 0 sines of 4t. So 4a minus 16b, the cosine part, needs to be equal to 34. And the sine part, 16a plus 4b, needs to be equal to 0. Let's reduce these a little bit if I can. So this turns into a minus 4b equals 17 halves, and 4, let's just leave that as is. A 16a plus 4b, because that's the exact opposite of this, equals 0. So when I add those together here, I get 17a equals 17 over 2. A is going to be 1/2. If a is 1/2, then let's come back to the second equation. That's 8 plus 4b is equal to 0. 4b is negative 8, and b is equal to negative 2. This b is 2, right? So now we have our xp is equal to, and I'm going to write it this way, e to the negative 2t times a cosine of 4t plus b sine of 4t, and then I'm going to distribute all that. I'll need the derivative of this, so let me go ahead and do that this way. Xp prime, which I'm going to need in just a second, negative 2e to the negative 2t times all of this plus this times derivative of all that, so 4 times a half, and then a negative 1, so that's a negative 2 sine of 4t, and then 4 times negative 2 is negative 8 cosine of 4t, so that makes xp prime equal to, and then we have e to the negative 2t times 2 times 1/2 is a negative 1 plus a negative 8 is a negative 9 cosine of 4t. And then you have a negative 2 times a negative 2 is a positive 4. 4 minus 2 is a positive 2 sine of 4t. All right. So negative 9. And I have a negative so let's keep going. I think all that's right. Negative 2 and positive 4, the positive 2. All right. Then we have x of t should be equal to, I got to come all the way up here to find it. I've got it written on my paper, so I'll just go ahead and look back here. Is C1 cosine of 4t plus C2 sine of 4t plus my xp is e to the negative 2t times 1/2 cosine of 4t minus 2 sine of 4t. So my x of 0 is going to be C1 plus 0 there plus 1 times, and then that's going to be 1/2 cosine of 0 is 1, and then that's 0, and this needs to be equal to x of 0 was 0. So C1 needs to be a negative 1/2. Good so far. And then x prime of t needs to be equal to negative 4C1 sine of 4t plus 4C2 cosine of 4t plus e to the negative 2t times negative 9 cosine of 4t plus 2 sine of 4t. And so x prime of 0 is equal to 0 plus 4C2 plus a negative 9 is equal to 0. 4C2 is 9. C2 is 9/4. So that gives me and x of t of -1/2 cosine of 4t plus 9/4 sine of 4t plus e to the -2t times 1/2 cosine 4t minus 2 sine of 4t. If you want to expand all that out, to write it instead as -1/2 cosine of 4t plus 9/4 sine of 4t plus 1/2 e to the -2t cosine of 4t minus 2 e to the -2t cosine of 4t. That would be great too, to do that. So that is that one, and I believe that is my last one for 5.1.3. I'm going to come up with some examples for you for 5.1.4 to go through. Your teacher may not assign them, but it's going to bring this forward into circuits like I talked about, and we talked about LR and RC circuits. But what if we put it all together and make an LRC circuit where we have both capacitors and resistors in there? If you're going to be an electrical engineer, you're going to need to know how to deal with the differential equations for that, and it follows this same process, and your electromotive force, your EMF is your E of t that's on the right hand side, that is the forced motion that the voltage from the battery is pushing that and is that force there that gives you the current that goes around and so on. So anyways, that is the same idea, how this is an application of forced motion, and I'll do a few problems like that for you in the next video before we move on to another section. So see you for the next video.